Okay, looking at question 7 of Electrochem 1 tutorial, we are looking at the oxygen fuel cell. So in this case, the fuel used is methanol. So in this case, the question is very specific. They say that at the anode, so recall at the anode for all reactions is oxidation. So methanol and water undergoes this oxidation reaction. So you can see the oxidation state of the carbon in methanol, alright, from -2 has increased to +4. Alright, another way of looking at it is that electrons are being lost. Right, so oil-rig. So this is oxidation reaction. So the electrons that passes to the cathode. Cathode is where the reduction will occur. So in this case, oxygen will produce water. So in this case, you're looking at the reduction reaction, O2 forming H2O. The question asks you to construct an equation. So this is quite easily done. To balance the oxygen, add a 2 in front. Alright, to balance the oxygen, then you have 4 hydrogen over here, you add 4 H plus, and then for 4 electron. Alright, do we need to know which medium it is? Yes, in this case we know what medium it is because in the oxidation half cell it's given as a H plus, so it must be acidic medium. Alright, so this is the equation at the anode, reduction equation, as written here. So we're supposed to construct an equation for the overall reaction. So for the oxidation half equation, this is the oxidation half equation. 6 moles of electrons, 4 moles of electrons. We look at the lowest common multiple. So in this case, the lowest common multiple is 12. So the 4 electrons equation you need times 3 to it. The 6 electron equation you need times 2 to it, and you sum them up. Okay, so lowest common multiple. Alright, so to ensure electron transfer. Okay, so this is how you can get the overall equation. Okay, so you have 3O2. The 12H plus over here will cancel with this 12H plus. Electrons will cancel out. Then 2CH3OH. In this case, you have 6 water here. You have 2 water here, and therefore you end up with 4 water over here and 2 CO2 because times 2 to CO2. Alright, so this is how you get the overall equation. Moving on to part 3, you see that the cell is capable of producing an EMF of 1.18 volts. EMF is also known as your E cell. So E cell equals to positive 1.18 volts. By using suitable data, we need to predict what's the E naught of this CO2 CH3 OH electrode reaction. So this is your methanol and CO2, so it's an anode, so this is in fact your E oxidation. So O2 and H2O is a reduction, so it's 1.23 volts. This is the unknown. So we substitute 1.18 into here. E reduction we know is 2.13 volts, 1.23 volts. So apply a formula, E reduction minus E oxidation. Submit the values. Your E naught for CO2 CH3OH is positive 0.05 volts. Okay, nothing new so far. It's all concepts that they discussed in the earlier questions. We move on to part 4. So what's the advantage of using a methanol fuel cell compared to hydrogen fuel cell? So first of all, methanol is less likely to be explosive as compared to hydrogen. This is a common answer given by students. One in addition thing is that methanol, we all know, is a liquid, whereas hydrogen is a gas. Typically for a liquid, it's easier to store and transport, because for a gas, we have to typically store them under high pressure. Okay, that's typically how we store gases, in the canisters under pressure. So it makes it a lot easier to transport and store methanol because it's a liquid. Okay, if you need to copy the answers, please pause the video now. I'll move on to part 5. Now part 5, they say that air may be used instead of oxygen as an oxidant. Give one advantage and disadvantage of using air as an oxidant. So in this case, advantage should be quite straightforward. So there's no extra cost in using air air is readily available and it's cheaper as compared to using just pure oxygen. What's the disadvantage then? Now, if you take a look at the equation that involves oxygen, this is the equation, right? So we talked about the two equations early on. In this case, it happens at the cathode. Oxygen is used at the cathode. So in this case, if we use air does not contain oxygen at 1 bar. In fact, the partial pressure of oxygen will be only at about, alright, because it's only about 21%. It's only about 0.21 atm, which is a lot lesser than 1 bar. So as a result, the partial pressure of oxygen gas will decrease based on Le Chatelet's principle. Equilibrium position of this will shift to the left, and as a result, your E reduction becomes less positive, and therefore, because E cell is equal to E reduction minus E oxidation, it becomes less positive. And what's the implication of it on the cell? It means that it will have a lower operating EMF. Alright, so the output by the fuel cell will be less. Okay, we move on to B. For B, we're looking at ethanol now. So for ethanol, the formula is CH3CH2O OH. We are looking at combustion. Alright, so in this case, O2, to balance, we balance the carbon first, so it's 2 CO2, and then we have 1, 2, 3, 4, 5, 6 hydrogens, so we need 3 H2O. So in total here, we have in total 7 oxygen atoms. So we have 1 here, and therefore we need to balance it 3 oxygen molecules over here to have 7 oxygen atoms on the left hand side as well. Okay, so in this case, state symbols are optional. Okay, moving on, we have the standard enthalpy change of combustion to be this, and entropy change to be negative 140 joules per mole per Kelvin. We are supposed to calculate the standard Gibbs free energy. So we make the use of a formula delta G naught equals to delta H naught minus T delta S. Okay, sub in your delta H be negative 1367. Entropy change delta S, take note of the units, is in J per mole per Kelvin. This is in kJ per mole, and since you want to find delta G, which is in kJ per mole, it makes sense for us to convert delta S into kJ per mole per Kelvin. So all we need to do is to divide it by 1000. Of course, temperature is given to be 298 Kelvin. Alright, so you see, negative 140 divided by 1000 and convert to kJ per mole per Kelvin. And then substitute in the value, you get negative 1330 kilojoules per mole. Okay, so the combustion of ethanol, highly feasible thermodynamically. Okay, moving on to the last part, B part 3, delta G and E naught cell are related by this equation. E cell equals negative delta G over ZF. Okay, in fact, it's just a simple manipulation of your delta G equals negative NF E naught cell formula. Right, basically I make E cell my subject, so E cell equals to delta G naught over NF, and you have a negative sign in front. So basically your N is the same as your Z. Okay, and they actually define for you. Okay, so we're supposed to use the equation we have written in part 1 to decide on a suitable value for Z, and hence calculate the E naught cell for the ethanol oxygen fuel cell. So in this case, we know what's delta G. Alright, we have calculated delta G. So that can be substituted over here. Okay, we know what's Faraday's constant, 96500, which means the only thing we need to know is the number of moles of electrons transferred per mole of reaction. So it's for this reaction on top in part 1. Are we able to look at this equation and tell how many moles of electrons are being transferred? Alright, not likely. And as a result, it's necessary for us to consider the half equation. So in this case, ethanol is actually oxidized to CO2. So you can balance the equation. Alright, so 2 carbons, 2 CO2. Alright, now once we are done with balancing the carbon, we can now go on to balance the oxygen. Now, since I have 4 oxygen here, I'll need to add 3 water molecules to balance the oxygen, because I have 4 oxygen here. I only have 1 oxygen here. I need to balance with 3 water to balance the oxygen. Once I balance the oxygen, then I go on to balancing the hydrogens. In total, I have 6 hydrogens from the ethanol molecule, and then another 6 from water. Therefore, I need 12H+. Once I have 12H+, the whole thing is just to balance the charge. On this side, I have no charge. On this side, I have a positive 12 charge, and therefore I need to add 12 electrons to balance the charge. For the reduction equation, it will be simply your O2 forming H2O. Okay, so O2 being reduced to form H2O. So in this case, how do I balance the equation? So first thing first, balance it with a 2 here to balance the oxygen. And since now I balance the oxygen, I balance the hydrogen now, I have 4H+, and therefore I need 4 electrons to balance the charge. So one look, you can see that the equation, for equation 1 you multiply by 1, equation 2 you multiply by 3. And as a result, the overall equation is what you have over here. So in 1 mole of this reaction, right, this entire equation, how many moles of electrons are being transferred? 12 moles of electrons. So Z equals to 12. So apply a formula, E side equals negative delta G ZF over ZF. Notice again this formula, common mistake. Delta G using this formula, delta G is in J per mole and is given over here. So read the question. Okay, so convert negative 1330 kg per mole into J per mole. So over here, I avoid excessive rounding off. So I use the earlier intermediate value 1325 times 1000. I divide by 12 times 96500. I will get a value of positive 1.14 volts. Okay, and that's question 7. Okay, moving on to MCQ. Okay, these are the answers for MCQ. If you wish to know the answers for the MCQ, you can watch out for the subsequent videos in which I'll discuss question 8 to 13.